Hi everyone. The topic that we are going to discuss today is introduction to angles from the syllabus of class 5. So before I get into the topic, I just want to give a brief introduction about me. I'm Luhut Prakash Sundara Rajan. So currently I'm doing my final year of bachelor's from NIT Puducherry in the Department of Electronics and Communications Engineering, and I'm also an exchange student in IIT Madras in the Department of Aerospace Engineering. So let's dive deep into the topic. So basically, what are angles? So that's the question here. Uh, we are just getting started to know about angles. So what are angles? We have multiple questions in our mind, like what are angles, where do we use them, and what are its types and how to measure them. Okay. So there are. We'll address all these questions one by one. So what are angles? So that's what we are going to look at it first. So the angle is just the angle is nothing but the measure across the inclination, the measure of inclination between two lines. The measure of inclination between two lines is angle. So let us assume this is 30 degrees. Okay. So this is angle over here. So this is one line and this is one line. So the inclination between two lines is nothing but angle. That's the measure. Okay. So where do we use them? Like there are certain examples given in your book. For example, look at this bridge example. So so the designer of the bridge, they predefined the angle such that the the bridge will lift to a certain angle or only up to a certain degree. Let us assume this degree to be 60. So the lift will never go beyond that. So the lift, the bridge is programmed in that particular manner. So where else? So we use it in our cell phone towers as well. The range, the signal that you get is at a particular angle, right? So that's why it's placed a bit higher so that it can reach everyone. And the buildings, the construction of buildings, and especially the bridges, and everywhere we use these angles everywhere in our day-to-day life, and we'll come across all these examples one by one. So this is angle. Okay. So the second question is, where do we use them? We just saw there are multiple examples, like construction and maybe construction of bridges, and for example, let us assume you're short and you're looking at a tall guy. So there is an angle of looking at him, right? So there is an angle. So let us assume you're here, and there is someone elderly, and you're looking at that particular person. Okay. So this is the angle. This particular thing is the angle that we are talking about. This is the angle that we are talking about. So let us assume this to be 45 degrees. It can be. So how do we measure them? We measure them in degrees or radians. There are two possible measurements, which is one is the degree and the second is the radian. So let me write down here. So how do we measure them? So how do we measure? So the units, basically I'm talking about the units. One is the degree, second is radians. So there is a bit of conversion factor between degree to radian. So let us assume 1 degree is equal to, okay, so 1 degree is equal to pi by 180 radians. So what is the value of pi? That is 3.14. Okay, this is an approximated value. So I would like to give up this particular symbol. Yeah. So this is a basic conversion factor between degree and radians. So mostly in this particular session we'll be talking we'll be using the degree as an unit. So whenever we address angles, we mention it in degrees. So there are certain types of like angles as well. So we are done with this question, we are done with this question, and what are its type? The third question that you might ask. So there are certain types. Let us discuss about those types. Just a second. Okay, there we have it. So when the angle is less than 90 degrees, when the angle is less than 90 degree, we call it acute angle. So when the angle is exactly 90 degrees, so this is said to be 90-degree angle. So where one particular line is exactly perpendicular to the other line. Okay, so this is said to be a 90-degree angle. So we call this as right angle. And second one, so when the angle is more than 90 and less than 180 degrees. Okay, when the angle is more than 90, exactly this example I'm talking about, when the angle is more than 90 and less than 180, we say that as obtuse angle. When the angle is exactly 180, it's just like a straight line. Okay, so we call that as straight angle. Then if the angle is greater than 180, can you see this? It's just greater than this particular 180 degrees. So this is 180 and this is greater than 180 degrees. So we call this as reflex angle. And then we have the third thing, which is a full angle. So that's the exact 360 degrees. Okay, so it completely circles around. So imagine, I would like you to imagine two sticks. Okay, imagine two sticks. One stick is exactly lying across the ground. Let us assume this. And the other stick can roam around. Okay, the other stick can roam around. Let us assume this particular stick. So what is the angle? Angle is nothing but, so just a second. The angle is nothing but, if this exactly is 90 degrees, so the angle between this yellow line and the green line is almost 90 degrees. So this is said to be a right angle triangle. Whenever right angle triangle comes into picture, we always mention a square box when you represent an angle, right? Then when the angle goes less than, this is said to be a acute angle. When the angle goes, so all the way from 0, this angle is 0, maybe this is somewhere around 45 degrees, and this is exactly 90 degrees. And now, so whenever you roam across this region, like between 90 degrees and 0 degrees, this is said to be a acute angle, as mentioned in this first image. Okay, as mentioned in this first image. Then the second one is the right angle, which is exact 90 degrees. And whenever, so the third one is far more simpler. So when this angle is said to be 180 degrees. So the angle between this and this is 180 degrees. Okay, the angle between this and this is 180 degrees. Okay, so whenever the angle between both the lines is in the range of 90 degrees and 180 degree, then it is said to be a obtuse angle. So when it is at exact 180 degree, just like the image, just like the example that is right here, which is, then it's said to be a right angle. Then if it's more than 180, so this is exactly 180. If the angle drops, if the angle drops, so what happens? Yes, again. Yeah, if the angle drops, so the angle over here right now is more than 180. The angle over here right now is more than 180 degrees. Okay, so now what is this? This exactly, so the angle over here is more than 180 degrees. So let us add angles. So can we add angles? That's the question here. So right now this is 180 degrees. Okay, so my question is, what is the angle made by this pink line? What is the angle made by this pink line, which I marked with the red arrow? What is the angle made by this pink line? So pink dotted line. So with respect to the green line, that's the question here. So this is the angle. Can we add them? Yeah. So what is that? So before you ask that, like, now what is the angle made by the yellow line? That's 180 degrees. So what is the angle made by the yellow and the pink line? So that's 90 degrees. That's almost 90 degrees. So now when we add them, we get the angle made by the pink line with respect to the green line, so which is 180 plus that are 90. So now 180 plus 90 degrees is equal to 270 degrees. Okay, so this is what the main concept that you need to understand, that angles can be added and angles can be subtracted as well. So here angles ANGLES can be added and subtracted. Okay, so how do we represent an angle? That's the next question. How do we represent an angle? So what's the question here? How do we represent an angle? How to represent an angle ANG. Okay, so that's the next question, which is the fourth question we are talking about. So now let us assume this is the angle, this is the line. Okay, so this is A, and this is B, and this is C. When you want to represent an angle, so you mention with a small L kind of a structure that denotes angle. Okay, so here this is the vertex point. So the B, angle B is the angle so we are talking about. So whenever, if the vertex always lies in the middle, so B comes here. So next A can be here and C can be here, or else the other way is the C can be in the first, B is always in the center, and next A. So because we are representing B and B is the vertex. What is vertex? The point where the angle is mentioned or marked, that's called vertex. So what about this figure? Like it can be, it is, so D, angle D, E is always in the middle, and F, or the angle FED, E is always in the middle. So what's the vertex? Vertex is where the angle is marked, right? So E is the vertex. And what is this? The arms of the angle. So there are two arms. So in the first case, we had A and B is one arm, the first line, stick you can assume, and B and C is the other arm. Like in this case, so D and E is one arm, and next E and F is at the other arm. Now what about this? So we have angle P R, sorry, I made a mistake here. So PQR is the right answer. Or the angle RQP is also the right answer. Q is always in the middle because Q is the vertex here. And next, so we have then what are the arms? So we have P and Q, and R and Q are the two arms. This can also be interchanged, right? So Q and P or Q and R. You can write in any particular manner, that doesn't matter. Only thing that matters is the Q. Q is the vertex, and vertex should always be in the center for a particular angle. Whenever you denote an angle, Q is always in the center. Okay. So these are some of the examples. Like for example, so whenever you look at the right angle triangle, so whenever the clock strikes, this is 12, whenever clock strikes 3 o'clock, so you see a right angle triangle. So this is a right angle triangle, right? So this is a right angle triangle made by the clock. So every day you look at a clock moving across the entire 360 degrees. So it moves 1 over 1 over 1, and it moves slowly, that you can notice and observe in your day-to-day life. And this is the electric pole that you look at it everywhere, right? So there are angles over here, and these angles are almost constant. And the bicycle that you ride, even that has angles. So the angles, generally a triangular structure gives much more stability to any particular object. So that's why most of the bicycle uses triangles. Triangles are much more stable structures. Okay, so every triangle has angles. So look at the ladder, and we have angles over here as well. So this can be around this is around 90 degrees, and this, even the tilt that you see. So let us assume this as one stick and this as other stick. So this is the angle between two particular ladders. Okay, and here, yeah, even in the stairs that you use on the daily basis, so we have 90-degree angles everywhere. Okay, and of course the branches angles in a branch is not always constant. Yeah, it changes with respect to tree, but yeah, so they do follow a certain rule to decide the angle where the branches should be. So the angle made by the branch is this. Okay, this is how you measure angles. Remember one more thing, the most important thing is the angles can only be measured for straight lines. So if you look at a curve path, let us assume that this is one curve path, so you can't measure angles between the curve path. So this is not an angle, so you can't measure angles for a curve path. So angles can only be measured for a straight line. Okay, yeah, there's a very important part, like remember. Okay, so how do we measure angle? So we measure using a device called protractor. So let me put the image over here, just give me a second. So the next question is, how do we measure it? So what is the device? So how to measure? So what is the device that we use? That's the protractor over here. So here the angle made by the ground line, so I call this line as a ground line, which is ln. Ln is the ground line. From ln to this particular, so wherever you want to measure, you just uh, drop the line across the ground line, then you get the particular degree where uh, how much ever it wants, whatever the degree that the stick is tilted, you can just measure using the protractor device. And every geometry kit has a protractor in them. Okay, so that's it for today. So definitely I hope to meet in the next class, and thank you.